Now, here comes the next part. Now, the next part is if you are given forces, like many forces acting at a point. So this one is F1, this one is F2, this one is F3, and this one is what? F4. So the angle this one is inclined to is theta 1. This one is theta 2. This one is theta 3. And this one is what? Theta 4. They are all inclined, remember, to the horizontal. This is the horizontal, this is the vertical. This is Y, and this is what? X. Now, you know what will happen? You have to find the resultant of all these vectors. You see all these vectors, they are acting at this point. See, they are all acting at this point. Yes. So you have to find their resultant. Then what will you do? First of all, you will add all the horizontal components of this vector. Every vector here has both vertical and what? Horizontal components. Now let us start. Now we now have, we say, let fx be the sum of all the horizontal components of this vector. So we now have fx is equal to f1 cos theta 1 plus f2 cos theta 2, then minus f3 cos theta 3 minus f4 cos theta 4. You'll be wondering, why the minus? Do you know why? Because this is positive x-axis and this side is what? Negative x-axis. Do you understand? Remember, this vector, like, it has components in horizontal direction, all of them. Do you understand? So this one, each component is along the negative x-axis. That is the horizontal component, including this one, along this negative x-axis. Do you understand? So it must be negative because you define this side as positive and this side as what? Negative. So every force on the left here is negative. It has a negative horizontal component. Every force on the right here, we have what? A positive horizontal component. You see? So right, left, right positive, left negative. So let's go on. Now we have Fy is equal to, this time now, let me finish writing. So F1 sine theta 1, F1 sine theta 1 plus F4 sine theta 4, then minus F2 sine theta 2 minus F3 sine theta 3. You see, in this case, we are talking of up and down now. Okay, so up is positive y-axis, down is what? Negative y-axis. So every force going up has what? A positive vertical component. While every force going down has what? A negative what? Vertical component. Do you see? So you don't you see what I did here? F1 sine theta 1. Do you see? They are all up. F4 sine theta 4. Do you see? So the other ones, F2 sine theta 2, they are all down. Good. So this, we have summed everything. This is the sum of all the horizontal components. This is the sum of all the vertical components. Okay? So after getting all these things, now the resultant will now be, the resultant force will now be equals to square root of fx squared plus what? Fy squared. You'll be wondering, why this formula now? How come this formula? You know that you summed all the horizontal components. Let's say the sum gave us a vector like this. This is the vector. It gave us fx. Now you summed all the vertical components. Now let's say the sum reduces to a vector. This vector now, fy, like this. Remember, the resultant is what this vector is going. This is the sum of all the horizontal components going like this. This is the sum of all vertical components going like this. Remember, to sum a vector using the triangular law, it is from tail to tip. So this is the resultant. You see now, this is the resultant. So this is your FR. Now this is the theta, angle theta. You see? So this thing can go down. No, the resultant can be negative. Do you understand? Yes. I mean, no, it can be negative because of the squared here. Okay. So, but know that this you can have this thing like this, like this. It can go like this. Okay. Like this. You understand? It can go like this. So in this case, this is the resultant. Okay. But do you know what will happen? Uh, when calculating the direction, that is when these things matter. You know, don't worry. By the time we solve questions, you will understand what I wanted to explain here. Okay. Let's just leave it for now. So now this is the resultant. You see? So from Pythagoras theorem, so we now have fr squared is equal to fx squared plus what? Fy squared. Okay, so therefore fr squared is equal to, sorry, fr is equal to square root of fx squared plus what? Fy squared. You see? So it's from Pythagoras theorem, or some call it Pythagorean theorem. A Pythagorean is a follower of Pythagoras. Okay? You know, they believe that Pythagoras is not the owner of the theorem, although they say that he's the first person that proved the theorem. But the theorem has been in existence, yes, I think maybe thousands of years before Pythagoras, or hundreds of years, but the theorem existed before Pythagoras. So don't be surprised when they use Pythagorean theorem instead of Pythagoras theorem. But Pythagoras is a great mathematician, though. So whether they call it his theorem, so he deserves it. So this is it. So this is how we find the resultant of more than two vectors. So you see that any vector you add here, you can use this and get their resultant, even including two vectors. So it can work. Yeah, it can work. So learn this very, very well. Okay, see you in my next video with examples on this. Okay.